Hello friends, welcome to KMaths-Foundation. I'm very delighted to be with you once again. Today we are going to consider one of the topic in the senior class, in the senior category. I don't want the senior class student to be left out. That is why I decided to bring in senior class topic, so that they also can maximally benefit from this channel, as we are doing junior class lesson on one side, so also the senior class lesson on the other side. Thank you for your cooperation. So let's go into what we have today. Today we are going to consider a topic in mathematics called surd. So I'm going to teach you all that you need to know in surd. Let's go. Alright, as you can see from the screen, this is the naming aspect in surd. A surd is basically an expression involving roots. That is, you may have square roots or cube roots or other roots, but this is how you can recognize surd. You may be asked to solve a problem that may involve roots, that may contain, for example, you may have something like this to solve, so that involves root. That is how to recognize surd. But how do you go about this? But let's first of all deal with the naming aspect. As you can see here, this arrow, this particular diagram here, this is the root and is called the radical. This is the radical. As you can see here, this is the radical, while this 4 inside is the base. This is the base of the radical. This is the radical sign, so this is the base, or you call it radicand or the base, while this one outside is the index. This is the index or the order at which the root is given. So this is the order, or you call it index. So, and I want to say something about this. You see here I have roots. This is a square root here. This is not a cube root. If it is cube root, they will give you 3 here to show that this is a cube root. But if it is square root, they don't need to add any number. They don't need to add 2. Square root normally have this 2 at the back is invisible. We don't used to put 2 there. So instead we just write something like this. It can be 16. We just say square root of 16, and you find it. So if it's not going to be square root here, they will indicate by writing the type of root it is. So let's go to the roots of surd. Let's look at some of the roots of surd that we have here. We have root 1, root 2, root 3, and root 4, 5. So here we have the first root. Please, these rules in surd are very, very important. It will help you to know how to calculate or solve any problem in surd. Now we have p roots. We have square root. You know this is square root of p and q inside the same root. P and q, these are different letters. So how can we solve this? So there's a way of breaking it down to help in solving. So these are different letters. We have P and Q. So we have this, how to break it down. So we have P multiplied by Q. P multiplied by Q. So we now have P itself alone multiplied by this Q itself alone. So this is how you can solve this. So this is called multiplication rules in surd. This is multiplication rule because of this sign here. So, and there's also an invisible sign, multiplication sign in between this particular P and Q. That's why we now split it into this form. So let's go to the second one. This is division rule. We have one square root here. Inside the square root we have P over Q. So but we have this, the further breakdown, we have root P. Can you see square root of P divided by another square root of P, where you can solve direct. But look at this root 3. Please, you are still going to understand these rules very well as we go into the solving or calculation aspect. So we have P plus Q is not, this sign is, it means not equals to sign. Not equals to sign. This is the meaning of not equals to sign. So we have P plus Q. Please, I may not be able to tell you the why it is like that. Here we have P and Q, we can write it in this form, but why can't we write square root of P and separate it plus square root of Q? Why can't we also do it like this? So I'm going to teach you. Maybe I think I will use another video because of the time. I don't want to waste time at all. So I'm going to teach you why it's not, you are not having why it's not like the multiplication sign. So this one is not equals to, if you are given a number like this, you cannot simplify it to this form. It's not possible. And also this it also implies to the subtraction sign. P minus Q is not equals to square root of P minus square root of Q. And also this is rule 5, where you have P over square root of Q equals, this is called this rule is called rationalization in solve. So we are also going to do that. It's going to be on a separate video, this particular aspect, because it involves a lot of calculations. So let's move on now. We are still going to understand these calculations one after the other. These rules. Sorry. Let's go to what we have here. We have basic forms of sort. Let's look at these basic forms of sort and non-basic form of sort. So how can you identify basic forms of sort? Now, a sort is said to be basic if it does not have a factor that is a perfect square. A perfect square is what's like a perfect square is like 9, because the root of 9 is, it will give you 3. The root of 25, the square root of 25 will give you 5. The square root of 16 will give you 4. So those are perfect square. Like the square root of 4 itself will give you 2. But in this case, a basic form of a sort is the one that has no perfect square. It cannot be broken down further into a perfect square. So you will still understand as I explain here. But let's go to, that's how you have 11. Sorry, you have 11, square root of 11, 7, 3, 2, 5, and 10. So all these ones are basic form of sort. Why? Because it cannot be broken down into two factors, where one of them we have an exact square root. So these ones cannot be broken down into another factors, so they are basic form. But look at these examples of non-basic form. We have square root of 27 is equals to 9 times 3. Non-basic form of can be broken down into two factors, where one of them has an exact square root. Now, one of these number must have an exact square root. One of these number must have an exact square root. Like the one that you are going to, we have 27. If you think very well, you see that you can break 27 down. 9 times 3, 27. But one of those numbers you will use must have an exact square root. Like example, there's exact square roots to be, if you have this one will become, let's rearrange it. We have 9 multiply by 3. So 9, the square root of 9 is 3, because 3 times 3 is 9. So the square root of 3, this is an exact square root that will give you 3 itself. It will. So the exact square root of 9, punch your calculator, you see it is 3. Then this 3 does not have an exact square root. So this 3 will come, it will become like this. 3 roots 3. But mind you that this 3 is not in there, so it's not the, when we talked about the naming the other time, we talked about cube root. So this is not cube root, is this one is standing alone. 3 multiplied by root 3, so it's going to give you 3 root 3. But look at this one again. This square root of 8 into 4 times 2. This one is broken down further into 2 factors, where one of them, that is 4, has an exact square root. So 4 has an exact square root to be 2. The square root of 4 is 2, but this one does not have an exact square root, so it will still give you 2 roots 2. That is the answer. So let's go to another aspect of sort. We have similar sorts. So how can you identify similar sorts, or how can you solve question like this in similar sort? Sorts can be similar if, look at this, if the base of the radical, this is the radical, so if the base, this base here, this one, they are the base or radicants. So if the base of the radical contain the same number, if the base of the radical contain the same number, so this is the base of the radicals. If they contain the same number, or if they have the same elements, then it is similar sort. What this now, if these roots have the same elements with this root, then they are similar. So you are going to pick one out of it. This is what I mean. And this addition sign, we are going to involve this sign to, as we add this 2 plus 5. Now 2 plus 5 will give you 7. Now, and you will now pick one from between this and this, because they are similar. So we now have 7 roots A. That is how to solve it. That's the answer. Very simple. 7 root A. 2 plus 5, 7. Then you pick one because they are similar. If they are not similar, you don't pick and you don't add. So don't worry, you understand later. Now we have 4 root 3 minus this minus sign, minus 2 root 3. So because these roots are the same, the base or the radicands are the same, we pick one of them. So as we just solve the normal calculation with the signs, now we have 4 minus 2 is 2. Then pick one. That's how to solve it. 3. Just pick one of them. Sorry. But look at this number 3. Number 3, we have 6 root 3 minus 3 root 2. How can we solve this? These are not the same. This 3 here and this root 3 here and root 2, they are not the same. So can we just say 6 minus 3 to give us 3 root what? So we are not going to solve it. We are going to leave it like this. and you move on. So let's go to the next aspect, which is conjugate sort. Wow, I love this. Conjugate sort. Now find the conjugate of the following. This aspect is very important. We have root x minus root y. How do you find the conjugate? It's very simple. Finding the conjugate, the sign in this middle will change. If it is positive, it will change to negative. If it is negative, it will change to positive. Look at this. This is the conjugate of root x minus root y. This is the conjugate. Can you see? The sign will change to positive. That is the answer. Very simple. Let's go to the other one. Find the it depends on what they ask you to do. If they say find the conjugate, then you move forward to change the sign. This sign is positive, change it to negative. That is the conjugate of the sort. Please, I want you to share this video to your friends, share it to your colleagues. I want you to do that and tell them to subscribe. And you also, please subscribe to this channel so that you can encourage the teacher by clicking that red button. Thank you very much. But look at this one here. We have minus 3 root 5 minus root 7. So how do you do this? Should we change this sign or change this sign? I told you the sign at the middle, so you leave the first sign. It only involves the sign at the middle. It's very big. Plus, do you see? Root 7. Please, you are free to ask questions. Use the comment box below to ask any question you want. Do you see now? Let's move to the calculation aspect. As we are starting the calculation aspect, so we have I want us to be very fast in this sort calculation. So we have root 3 times root 2. How do we solve this? Root 3 times root 2. Now in sort, if you multiply the roots of different numbers, so you get the answer in root form. For example, it's just like when you say 3 times 2, that is 6. So root 3 multiplied by root 2 will give you root 6. Root 6. But look at this. If you have root 3 multiplied by ordinary 2, so here you cannot have root 6 like this because of this one is not having a square root. So this is how to solve it. So root 3 times 2 will give you, write the first number that is not having root first, 2 root 3. Please subscribe to this channel. That is the only way you can encourage the teacher. God bless you. 4 times 3, sorry, 4 times root 3 will give you 4 root 3. I want you to understand this terminologies in sort. 4 times 3 will give you 4 root 3. But look at this. If you have roots, let me write it here. Root 3 times the same root. The answer is what? Tell me the answer. Is 3. Yes, it's 3 because any root multiplied by itself will give you that particular number. If it is root 2 multiplied by root 2 will give you 2. If it multiplied by another root 2 give you 2. If it's root 4 times root 4, it's going to give you 4. Root 8 times root 8 will give you 8. So because of our time, let's go to the next one. We have root 48. So how do you solve this? Root 48, very simple. Remember, in our non-basic form of solve, that we can break it down into two factors, that one of the factors must have an exact square root. For example, this is 48. So what can you do? How can you break this 48 into a simple number? We have 48. That we can use 16 times 3. 16 times 3. 16 times 3 still equals to this. Sorry, still equals to this. We have 16 multiply by 3. So what will it give us? What is root 16? Root 16 is 4. Root 3 is root 3. Root 3 is not a perfect square. 16 is a perfect square. So we have 4 root 3. That is your answer. Yes, this one is 64. So you can also break it down into 16 times 4. 16 times 4 is 64. Can you imagine? 16 times 4 is 64. Now let's look at this. These two, they are perfect square. 16 is a perfect square, 4 is a perfect square. So the square root of 16, okay, let me rewrite it. The square root of 16, sorry, let me write it here because of time. The square root of 16 is 4 times the square root of 4 is 2. So 4 times 2 is 8. But this is a long calculation. If you know the exact square root of 64 is 8. 8 times 8 is 64. So just write 8 instead of going through this process. Now solve the following as a single solve. That is, you must make your answer a single solved, not this. Now 2 root 3, how can you turn this to a single solve? It's very simple. Remember that this is 2. This 2 was transformed from the perfect square to this. Is as a result of the perfect square that we arrive at this 2. So you are going to change it back. This 2 now, the perfect square that give us this 2 is 4. To turn it back, sorry, let's do it like this, because we are transforming it back, or we are changing it back to the way it was before. Can you see? This is a question. It was this that will simplify, that will arrive at this. But at times they may want to test what you're doing, if you really understand it, by giving you this to solve in a single solve. So just go ahead and give us write the answer. This is 4 now. This 4 is a perfect square. That's from this 4 now. When you solve this 4, the square root of 4 is 2. Then you have 2 root 3. But they are now asking you to change it or turn it back to a single solve. So this is how to do it. So now that you have changed it now, so what do you do to make it a single solve? Just multiply. Root 4 times root 3 will give you root 12. I told you different roots can multiply themselves like this. Like what we have here, root 3 times root 2 will give you root 6. So root 4 times root 3 will give you root 12. This is a single surd. Look at this also, the same process. So when you change this, what do you have? You have 16. Remember, is this 16 that was calculated in square roots that give us 4 root 2. So if we calculate this one together, root 16 times root 2, we have root 32. Root 32. Very simple. Very simple. So this is where we'll stop. This is the part 1 of the surd. Please subscribe to this channel. Share it to your friends so that they can also benefit from this great topic. Like it and comment in the box below. Thank you very much. See you in the next video.